The voltage divider is one of the most commonly encountered electronic circuits. The purpose of the voltage divider is to take a voltage input, and by placing that voltage input in series with two resistive elements and measuring the potential across one of those resistive elements, we'll find that the output voltage has decreased or been divided relative to the input voltage. And the output voltage will be related to the input voltage by the choice of resistors 1 and 2. Now, using the concept of Kirchhoff's voltage law, we can derive the voltage divider equation. And because the voltage divider is commonly encountered in circuit analysis, knowing how to quickly determine the output voltage based on the input voltage using the voltage divider circuit equation will be very helpful. So what we're going to do is derive that. Now, in order to determine the potential that's developed across one of these resistors, either R1 or R2, we first need to determine how much current passes through R2. And that current that passes through this resistor, R2, will be the same as the current that passes through resistor 1. So in order to determine this current, what we're going to need to do is to determine the equivalent resistance of the circuit. So I'm going to reduce this circuit into a single equivalent resistance, Req. And we know that since R1 and R2 are in series with each other, it will be R1 plus R2. Knowing that that's the equivalent resistance, we can determine the current that passes through that by rearranging Ohm's law. So I is equal to the potential that's provided to this entire circuit divided by the equivalent resistance. In this case, we know that the equivalent resistance is R1 plus R2. So the current provided to this entire circuit is going to be Vn divided by R1 plus R2. Okay? Now that we know the current, again that passes through this resistive element right here, we can determine the potential that's developed across R2 by multiplying this current by the resistance value of R2. That we've called Vout. So Vout is going to be equal to R2 times I, which in this case will give us R2 times Vn over R1 plus R2. This is the voltage divider equation, and typically it's rearranged slightly. And we usually rearrange this so that to pull the input voltage out front, and the input voltage is then multiplied by a ratio of the resistances. Okay, so in this case, the output voltage is going to be the input or the supplied voltage multiplied by the ratio of R2 to the total equivalent resistance of the circuit. Now, if we performed the same analysis, except we wanted to determine the potential that is developed across R1, we would repeat it in much the same way. Except now, we're going to look for the voltage output across this resistor. Well, the current is going to be the same. Now, when we determine the output voltage, instead of multiplying by R2, we're going to multiply that current by R1. So our output voltage in the first case is given by this equation right here. In this case, if we're measuring the output voltage across R1, the voltage divider equation tells us the following. It's the potential that is supplied to the circuit, Vn, multiplied by R1 divided by R1 plus R2. So in this case, since R1 is the resistor across which we're measuring the output voltage, that's the one that goes in the numerator. Here, since R2 is the one where we're determining the voltage across, we're going to use R2 in the numerator. And it's just that simple. That's where the voltage divider equation comes from, and this will be a handy equation to have memorized and understand how to use.